Number 40, section 4.3, page 206. Here W is a linear combination of given or specific fixed vectors, three vectors, okay? So they give you three vectors, and all possible linear combinations of those three vectors is what W is. Okay, so we want to show that W is a subspace. Now, we studied that before in section 4.4, but this is an exercise from section 4.3. Section 4.4, we study this kind of set. That's the span. It's the span of vectors. So those are the three vectors. The span is all possible linear combinations of those vectors. In 4.4, there is a theorem that shows that span is a linear combination. The span is a subspace. But in 4.3, we didn't know that. And in the exercise, they define that. See, if you read the exercise, it says, at the end, it says, this subspace is called the span of x, y, and z. Okay? So we want to show that this is a subspace. But it's pretty simple. All you have to do, remember, to show that a set is a subspace, all you have to do is to pick two vectors in there, two general vectors in the set. If you add them and the sum is still in W, and if you multiply by a scalar that is still in the W set, then it's a subspace. Okay, let's pick two general vectors. Let me write them here. Okay, here it is. Here's what W is. It's a linear combination of those three given fixed vectors. And I put an arrow on top of them in purpose just to show you that these are not real numbers. Okay, X, Y, and Z are not real numbers. They're vectors. The scalars, of course, are real numbers, but not the vectors. They're from some vector space. Okay. So let's pick two vectors in W. Okay, I picked U and V. So they're in W, therefore U is a linear combination. So let's write here like A1 X plus B1 Y plus C1 Z. And V is also in there. So that means V is a linear combination of those three vectors, Z, Y, and X, Y, and Z. I can write as A2X plus B2Y plus C2Z. Okay? Now let's add the two vectors, U plus V. So if I add the two vectors, that means I'm adding these two expressions. And if I'm adding the two expressions, look at the first term, A1X, A2X. And in vector spaces, we can factor, right? It's the distributive property, one of those axioms. We can factor X out. So this becomes A1 plus A2X plus B1 B2Y plus C1 plus C2Z. Well, look at that. It's a linear combination of those three vectors again, right? There's a scalar times X plus a scalar times Y plus a scalar times Z. So the sum is still, is in W, right? This thing is in W. Well, what happens now if I multiply by a scalar C, pick a vector U and then multiply by a scalar? Well, this will be C times U, which is this whole thing here. Let's see if I can copy that real quick. And let's paste that there. That's U. And then, well, multiply the scalar times each one of them, each term. That I get CA1 X, CB1 Y plus C1 Z. And look at this. It's, again, a linear combination of those three vectors. So this is in W. Conclusion, W is a subspace of V. That's the end of it.